evaluate the following, and here we have 4 fraction division problems. Let's go through them one at a time. First, we have 2/3 divided by 4/7. The rule when we're dividing fractions is that we can change it to a multiplication by flipping the second fraction. So we can write this as 2/3 times 7/4. And then it becomes a multiplication problem, and we already know how to multiply fractions. We do it straight across. 2 times 7 is 14, 3 times 4 is 12. We can reduce this by a factor of 2, leaving us with 7/6. You can cross-cancel, but only after you've changed it to a multiplication. We can't attempt to cross-cancel while it's still a division problem. That's only something we can do when it's multiplication. Let's look at the next one. 5/8 divided by 3/4. We can change this to a multiplication by flipping the second fraction, or taking its reciprocal. That's the math name. All right, 5/8 times 4/3. We can do some cross-canceling here. The 8 and the 4 are both divisible by 4. So if we reduce those by a factor of 4, we're left with 1 and 2. And then we can multiply across. 5 times 1 is 5, 2 times 3 is 6. And we're left with 5/6. It's really up to you if you want to cross-cancel or if you want to multiply first and then reduce. Whatever you're more comfortable with. I usually will cross-cancel when the numbers are very large. Otherwise, when they're small, I'll do the multiplying first and the reducing afterwards. And the reason is, when we do our cross-cancellation, sometimes things get a little bit messy, crossing numbers out and writing new numbers up above them or below them. And that's space where you're more likely to make a mistake. So I honestly try to avoid that unless the numbers are big enough that it really helps. All right, enough tangential advice. Let's get into the next one. -14/15 divided by 2/5. We can change this into a multiplication by taking the reciprocal of the second one, so that becomes 5/2. And then here, these numbers are big enough. Let's cross-cancel. The 15 and 5 are both divisible by 5. If we reduce there, that gives us 1 on the top and 3 on the bottom. The 14 and the 2 are both even. If we divide those by 2, it gives us 7 on the top and 1 on the bottom. And then when we go across, remembering that our answer will be negative, 7 times 1 gives us 7 in the top, 3 times 1 gives us 3 in the bottom, and we end up with -7/3. We've got one last problem here. -64/35 divided by -56/55. Goodness, these are some large numbers. First thing I want to point out, a negative divided by a negative will be positive. These negatives will cancel, and so we can eliminate them. It's just one less thing to worry about. So I'm going to get rid of the negatives and I'm going to change it to a multiplication by flipping the second one and writing it as 55/56. Now this is a prime example of where we really should be cross-canceling. All the other ones we could have easily done without cross-canceling, but here multiplying 64 times 55 and 35 times 56 just seems unnecessary. So let's try and do some reducing. If we look at the 35 and the 55, we can see those are both multiples of 5. If we reduce by a factor of 5, it leaves us with 11 on the top and 7 on the bottom. Now, if we look at 64 and 56, in my memory of multiplication tables, 56 is, I think, 7 times 8. 8 times 7 is 56. So that and 64 are both multiples of 8. So if we reduce by a factor of 8, we get 8 on top and 7 on the bottom. And then we can't cancel those 7s because they're both in the bottom. You can only cancel something in the bottom with something in the top. So now we can just multiply across. 8 times 11 is 88. 7 times 7 is 49. And we're left with 88/49, our final answer.